Hey everybody, so with this video I want to start a series which is practical applications of AI for business. And within this series I will and go over real world use cases for AI within businesses. So I'm going to break down actual real examples of real clients, but I'm going to change things enough about them so that the clients won't get mad. And we'll go through and we'll dissect exactly what actual implementations of AI look like within an actual business environment and what it covers. The big thing off the top is I think that it's important to get away from the mindset of I want to implement AI for my business as opposed to I have problems that I need solved and let's see if AI can solve these particular problems for our business. And then so that's step one, right? And so step one, we're going to use our example of a company called Quickshop. And then Quickshop is a made up company that's in the Midwest. And they are a retail company of like gas station chains, like retail convenience stores located in Illinois, the Midwest. So Illinois, Wisconsin, Indiana, and Missouri, and that's their footprint. And they have a lot of issues, both within their fleet, so fueling their gas stations and getting on-time deliveries, and their truck utilization, and then as well as in the stores specifically. And then so analyzing their operations, we've broken down essentially their three biggest problems, and then so two of them are related to the store and their office operations, and then their biggest one is actually related to truck usage and their delivery optimization. They are not real efficient at all with their delivery. So we're defining the problem is that Quickshop is facing inefficiencies in its delivery system where fixed routes often result in longer delivery times, underutilized trucks, and higher fuel consumption. Our goal is to develop a dynamic routing algorithm that optimizes delivery routes based on real-time traffic data, maximizes truckload efficiency by minimizing the number of half-empty trucks, and reduces overall delivery times and fuel costs by taking into account road conditions, weather, and traffic. How we're going to do this, our solution? We're going to build a machine learning algorithm that utilizes route optimization and vehicle routing problem techniques, so VRP. These are common problems. And then we're going to integrate real-time data for example, traffic and weather, to dynamically update and assign delivery routes to our drivers. So essentially, we're going to create, in this instance, a genetic algorithm, and that's what we're going to do. So we're going to use a hybrid approach here. We'll employ an optimization algorithm for solving the vehicle routing problem with time windows, incorporating dynamic constraints such as the traffic and the weather. We'll utilize reinforcement learning for dynamic adjustments to the routes based on changing traffic conditions, a greedy algorithm for optimizing delivery routes on a static basis, ensuring that the trucks take the shortest path between deliveries, and a genetic algorithm for finding the near optimal solutions to the vehicle routing problem by continuously improving route combinations over time. And then so essentially we go through and we run our algorithm, and this is our genetic algorithm here. And then so you can see we have our delivery locations. In this instance, the company operates again in the Midwest, so Chicago, Indianapolis, St. Louis, and Milwaukee. And we need to optimize the truck capacity as well as the truck deliveries so that we can essentially maximize efficiency between those locations. And this is what our algorithm does, and the simulated output of our algorithm. In this instance, it's a simulated algorithm. I could utilize real-world Google data and apply a whole bunch of APIs and a whole bunch of different things to this and within this specific example, but just keeping the example very light here. Here it is with a lot of simulations of this data, but giving you exactly how this would work and how essentially we can combine multiple algorithms, and then in this instance, genetic, greedy, and reinforcement learning algorithms to create our problem and our solution to the problem. And then so from here, when we move on to our quick shop analysis, what we find is that they have a lot of problems in the store. Specifically, with their next problem, it's with a big problem that a lot of these companies face is inventory management and store operations. So Quickshop operates several convenience stores, and they face the following operational problems. Inventory overstocks and stockouts. The stores often overstock items that don't sell quickly, tying up capital in slow-moving inventory. At the same time, they face stockouts for fast-moving items, causing missed sales opportunities. Employee scheduling inefficiencies. Scheduling staff manually leads to overstaffing during quiet periods and understaffing during peak hours. And customer experience. Customers experience long wait times during peak hours due to the slow checkout processes. So what we're going to do is we're going to split this out into three different problems, and then we're going to create three different solutions. With the first solution, we're going to tackle the predictive inventory management. And the very first thing I'm going to do is pip install this package here called Prophet, Prophet. And then Prophet is very cool for machine learning and for inventory management and for optimization. It's really built out around all of these things. It gives you sales data, external data, all of it built in, right? And then so we just have to define a few different things. We just have to define our data within this. So our data is date, sales, and product. And then we create a model. We create a profit model. And then we utilize that to predict our future sales. In this instance, we're predicting our future sales of milk. And our predictions are that our future sales of milk are going to go through the roof. In this instance is kind of our predictions and how this breaks out. But giving you an illustration and a breakdown as to how this works and how this would work within a typical business organization. So then the next problem that Quickshop faces is that scheduling problem. So we decide to create a smart employee scheduling algorithm. Our goal within this is to use AI to predict store traffic and automatically generate optimal employee schedules to meet demand without overstaffing or understaffing. In this instance, we need to collect a whole bunch of data, and then we'll train the data, our model, on the data. The data that we need for this instance, in this instance, is historical traffic count, and then external factors like weather, holidays, local events, etc., to see how these external factors impact traffic patterns for specific days. And then in this instance, what we see and what we can see here is that Wednesdays are our peak days. And then so we need to staff higher on Wednesdays than we do on other days. And then Quickshop beforehand was staffing much higher than they needed to on Mondays and Fridays, which are actually their weakest days. And then so we were able to reduce costs there significantly by reducing staff overall. And then having these metrics readily available and accessible are just a thing of beauty when having these types of conversations overall. And then so lastly, the last problem that Quickshop has is like a lot of convenience stores, you have lines that come up with just like instantly, right? Like traffic will be all of a sudden fine. You'll be operating with one register, and then all of a sudden you'll need 5 registers out of nowhere, and then all of a sudden you'll be back down to 1 register. And then so we have decided to solve that problem by creating a queuing algorithm. And then so essentially the queuing algorithm recognizes spikes and then responds to the spikes immediately by opening more registers, and then depending on the spikes, and then the goal is to immediately solve for the spikes. And then we don't want like these big kind of movements in the graph are what we're trying to smooth out essentially. And then so within this, we create a very simple algorithm where we measure all of the traffic. We have our number of open registers, our queue length, maximum number of registers, and our peak customer arrival rate. We simulate all of this in this instance, although we could plug this in and very easily utilize real-time data and solve all of this. And then so that kind of leads us to the bottom line, like why do this with AI as opposed to anything else, right? And the bottom line to me is that utilizing AI for these tasks, it makes it far more efficient, cheaper, and there's no better way to get at this type of data, essentially for free, right? And then you could utilize complex applications, and I have done it. I've been within orgs where you're building out data lakes, ERP systems, CRMs, and connecting like that whole entire infrastructure together in order to just get at this data. And then so what AI does in this instance is it operates as kind of the glue in those instances, right? If you have that entity on the back end of multiple systems that stack, you plug AI into it, and then it essentially allows for these systems to talk to each other. The biggest kind of like advice that I've gotten throughout my entire IT career is that what you do within IT is that you make systems talk to each other that weren't ever designed to talk to each other. That's the bottom line. And then AI is kind of a universal translator in that instance, right? It's not going to replace your stack. It's not going to be the golden solution in any way whatsoever. AI is an augmentation tool. It will augment your stack. It will augment your performance. It will augment your data. But the ground infrastructure needs to be there in the first place. Like you need that foundation, or else there's nothing. It will crumble once you put AI in there as well. And so that's kind of the bottom line of all of this. And then so the foundation starts with understanding it. And so I hope this gives you a better understanding of how to utilize AI. I'll make more videos like this for more specific companies. And if you like this type of content, please like and subscribe. Thank you very much.